This is a little bit unfamiliar with the a to the x. That's a little bit of fun. Okay, so we know we've got a local maximum at 1.5, but that's not the x value, that's the y value. So that's what's making this a little bit tricky. But we definitely know we need to differentiate and set the gradient function equal to 0 and use that somehow. So clearly we've got a u and a v, so u equals a to the x, v. U dash is going to be that thing that we haven't seen before, which is okay. And vu dash plus uv dash, it's an external exam. We want to be quick, not pretty. What's going on there? Rubbing stuff out. V. U dash plus u v dash. So that's y dash. We're going to set the derivative equal to 0. So clearly we've got to factorise that thing. There is a to the x, there's a 1 plus x. And what's left here? There's a natural log of a 1 plus x, and a 2. So we've got 3 factors, set it equal to 0. Clearly that's not going to give us a 0, we can't do that. 1 plus x, so we're going to have a stationary point where x equals -1. We're going to have another stationary point here at there. So let's just work that out. That will be x equals -2 on log a. It's going to be -1. Yeah, -1, that'll do. If it's wrong, we'll do the video again. Okay, so that's important. I'll probably need some in this room here. So we now know where x equals that value there, we have a stationary point and the value is 1.5. So I think if I go 1.5 equals a to the x, well that's up here, -2 natural log of a -1. That's all in the power 1 plus the x, which is -2 on squared. Now this is a tech active, so we are just going to solve in that baby, and we're going to solve for a. And you should get a equals 0.4. Where is it? 0.028. Where's my calculator? 5, 2, 3, 8, 9, or 0.37485.6. You know, the numbers don't really matter because we've got the answer down the bottom of the page. But it's an unfamiliar situation because of this a thing here, and you've got a little bit of work to do because we don't know that x value. So very, very unfamiliar. But simple if you can do it. If it said to evaluate the reasonableness, then you've got a calculator, so you're going to sketch it. We know we've got a stationary point here at -1, and I think 1 goes like that, somewhere like that. and another one comes down, up and over. That was terrible drawing. But we've got these stationary points here and here happening at y equals 1.5. And we've got that stationary point also at -1 that we calculated before. Put them in your calculator because that's a terrible drawing. But anyway, good question. Like the question.